giving the opportunity to a few people that want to speak about what they learned in the last class to do so. So if you've got something to say, if you learned something and then you just want to reiterate or share what you learned in the last class, kindly indicate. A show of hands will do. Just raise your hand and I'll unmute your mic. Okay. So I've got one person. Okay, so Peter Babatunde wants to talk. So I'm going to unmute you right now. And then let's hear what you have to say concerning the last meeting. So I'm going to allow you to unmute yourself. So you can unmute yourself right now. Oh, sorry. I did it twice. So you can unmute you. Yeah, great. Yeah, so Peter, yeah.
Great, tutor.
You have the floor.
Oh, thank you so much for this opportunity. I really learned a lot at the last training we had of what AI is all about, the differences in the strong one and the of life, the artificial intelligence, and the data science, and the hacking or programming, how they all get their intersections.
Yeah.
And the most important thing is how the perception, the fear that robot will soon take over everything we will do was dispelled. Right? The lesson was so great. And as a pharmacist, I'm seeing a place where I can build a niche for myself, especially in this part of the world where we are just coming to embrace technology.
Yeah.
Thank you.
Yeah, that's nice. That's a good one. And just like you said, you're a pharmacist, but you are interested in this field. And that does shows that AI is actually everywhere. So if you do if you do research right now and you type something like AI in pharmacy, you will see a lot of things that has been done. So I think it's going to go a long way, even if you're not in the tech field. So I'm great. I'm glad you had a great time. And then hopefully you have another awesome time into this meeting. So that's a good one. Thanks for that, Peter. I appreciate it. Okay, so who else wants to talk? Let me allow one more person to talk. So who else wants to say something, right? So a show of hand, and I will allow you mute your mic. I'll mute your mic. Does anybody want to say something? You guys are shy. Anybody? Okay. Apparently no one wants to speak. But I'm sure that doesn't mean you guys didn't learn from the last class. I'm sure if I say type in the comment section, you guys would. But maybe we should do that. Okay, so I'm going to read a few comments. So type in the comment section what you learned in last class. I'm going to read a few. So, okay, Dimian Ike wants to talk. So why I allow Dimian speak? Others can actually type if maybe you are shy of speaking. You can type in the comment section what you learned in last class, and then I'm going to read a few responses out. So let me allow Damian to unmute his mic. Yeah, Damian, can you unmute your mic now? Oh, apparently, I think Damian is not able to talk. So I've gotten one comment in the chat box, so let me read that out. Where's my comments? Okay, so I think Glory Yusuf said that I learned how data science can be integrated into almost every field. Yeah, that's it. That's a very important thing to learn because it can be wherever you are. Data science has a huge role to play. So yeah, that's a good one, Glory. Thanks for that. So we'll get started in today's meeting. And then, as you all know, in today's meeting, we are hoping to get into programming. And then, like I said, we are going to use Python. So we are going to get started with Python right now. And then before I do, let's just set the foundation. So if you ask me what a programming language is, I would say it's just a set of code that allow us to communicate to the computer. Okay, so it's just like it's a way of interfacing with the computer through instructions. All right, that's what a programming language is about, and that's what program is about. Basically, it's just a way of allowing humans interface with computer, give instructions and get some response. So of course, there are a lot of programming languages based on the syntax and all those stuff. You have Java, which I think is one of the most popular. You have Python, very popular as well. You have C++. You have Ruby on Rails. You have JavaScript. You have a lot, right? A lot of programming languages. But just the way we ended our last class, we said the tools for machine learning, the languages you need are most likely or mostly Python and R. Okay, so you can also use R for programming machine learning models. But in this particular class, we'll use Python. Okay, so we'll use Python. So that's about that. So let's talk about what an IDE is. So basically, people call it an IDE. It's called Integrated Development Environment. Okay, that's what it's called, and it's just like a way. How will I put it now? It's a way where you can type. It's a place where you can type in your codes, and then you allow your Python interpreter to run your code. Okay, so if you install Python and Jupyter, you have the default Python IDLE or IDE, whatever I call it. So let me just find that right now on my PC. So let's say this is your environment, it's your Python environment. I type something like print. Don't worry about what the print statement is for now. I'm going to explain all the stuff as we go on. So if I type something like print A, you can see it returned A as an output. But this is a very crude way of writing code because a lot of things that should be done is not done. For instance, when I opened a bracket, I must close the bracket at some point. So what IDEs do is that they help you do all those things automatically. So if I'm using an IDE, when I open the bracket here, it should close the bracket for me and place my cursor inside the bracket. Okay. And then for stuff like when I opened a semicolon, as you can see, an apostrophe, sorry, as you can see, or a quotation, I should close it at some point. So what an IDE does is that it does all these things for me. And then when we get into using methods, functions, and all those stuff, IDE also help you, get access to the Python documentation. There are times when you want to just see, what does this function do? What are the kind of arguments it takes and all those stuff. So using an IDE, it's like a broader, it allows you to do things efficiently. So you don't have to be slack with how things are and then do everything on your own. Okay. So that's what an IDE is actually used for. I got a lot of messages, of course, on WhatsApp group concerning the kind of IDE to use. Some people were saying they had PyCharm, some people were saying they had Eclipse, some people were saying they had, some were saying they had Visual Studio, VS Code, and a lot of all those IDEs. Those are fantastic IDEs. But what we use for data science is mostly Jupyter Notebook. And that's because it allows you run your code in blocks. So you can run a code, see the outputs, then continue. And that's very important in data science because you want to see how things go per time. You can't just write the entire code and then expect everything to run smoothly. So it's always good for you to take it batch by batch, run a batch. Okay, maybe I mentioned the cycle of a data scientist, and then it starts from data collection, exploration, EDA, feature engineering, and all those things. So what this thing does is that you can pick each of those sections and do it, then run it, then go to the next session, do maybe EDA, run it, do feature engineering, run it, do data evaluation, data splitting, model creation. You do everything in batches. You all should download Python and Anaconda because Anaconda is what allows you to use Jupyter Notebook. So how many of you have Python and Anaconda installed on your PC? Okay. For those that don't have, right, it's very easy. So you come to your Google browser, whatever browser you're using, and you type something like download Python. Okay, download Python. It takes you to the first result is the official Python websites. So you come here right now, and then this is the latest version, right? This is the latest Python. You have Python 3.9.1. So you can download this. It's great. Once you download, you have the exe file, and you accept it. That's all. You accept all this thing and click next. The only thing to change is that you check the box where it says that you should add to parts. Okay, so when it tells you to add maybe Python 3.9.1 to parts, check that box, and that's all. So once you have Python up and running, you type again on Google, download Anaconda. Okay, so if you come here, type Anaconda, it takes you to the first results, and then you click on download here. It takes you to the list of versions they have. So this is a 64-bit system, this is a 32-bit system. Let me close. This is a Mac for Mac people that use Mac OS, and then you have all of the stuff for people that use Linux, Ubuntu, all the stuff there. So yeah, those are the stuff you need to get started. But if you do not wish to get these things, what you can do is actually use Google Colab. Okay, let me move away from incognito because it's going to cause problems. Okay, this is the incognito. Okay, let me just create a new tab. That's okay. So if I come here and type something like, say, Google Colab. Okay, so Google Colab is just a way of running Python codes right on the web. So you don't have to install any Python. You don't have to install any Anaconda. With Google Colab, you can run everything on the web and produces the results just as fine as you having those things. And in fact, this is great if you're going to run heavy deep learning networks, because those guys actually consume a lot of memory. They take a lot of power from your system. If you're running, for instance, CNN, convolutional neural networks, you need sometimes GPU to run those codes faster. So if you don't have GPU, a good GPU in your system, or you don't have a dedicated graphics memory, it's not going to run as smooth. So in those cases, it's good to use Google Colab, because these guys already have given you some GPU and giving you some CPU as well. So it's as simple as this. This is the documentation. So just see what it looks like and all those stuff. But if I come here to file and I come to create new notebook, I am up and running, trust me. I am. Okay, I need to sign in. So, well, I have to sign in. Let me not sign in as this. Let me change this to okay. It's in my personal account. Well, anyway, I'm going to use this. Okay, so these are for people that don't have Python and Anaconda installed. You can use this method, right? Okay, but for those that have Anaconda installed, I'm going to go straight to my Anaconda just after this. I would strongly advise that is to get Anaconda because except you're using a system that is not strong, or it's actually maybe doesn't have enough memory, or the processor is weak. Someone came up to me in my DMs. I was telling me he wasn't able to run the installation file for Python and was guessing that maybe his system was low. Well, it's possible his system processor was low and all those stuff because it was in a Core 2 Duo. So it wasn't very fast. And I'm advising him, or I advised him to use Google Colab to run his codes because this already has given you some CPU and GPU. I'm trying to see something is blocking it. But it has given you CPU and GPU already. Okay, so you can use Google Colab. All right, so let me just experiment again with a simple print statement. So if I come here and type print X and I run that code, it's going to take some time. Well, then it's going to print X for me. It's taking some time because this is the first time I'm running this code. Anyway, a print statement should not take that long. So as you can see, it printed X for me. And you can see this is what Google gave me. So this is a virtual machine anyway. For those that are going to get into cloud computing, you understand what virtual machines are. So this is like a machine in the cloud or a machine inside another machine, so to speak. right? So it's a computer inside a computer. So maybe somewhere in Google server, they have their cloud, of course, and then they uploaded a lot of machines, virtual machines there. So this machine has a RAM, of course, and an hard drive space. So you can see the RAM they gave me a 12 gig RAM, and they also gave me a hard drive space of 107 gig. So you should all say thank you to Google, right? So if you don't want to go to the stress of running your codes through your Anaconda, or maybe you don't have a very powerful system, you can use a Google Colab. But I noticed that this consumes data. We in Nigeria, outside there, they feel data is not a big deal, right? But here in Nigeria, data is quite a big deal. So when someone wanted to download Anaconda and he saw 400 and something MB, he was shocked. Well, to them, I don't think it's a big deal, but here in Nigeria, 400 MB is a big deal. So that's the situation we find ourselves in this country. So I get that's the issue with that. It consumes data, because I tried running a code on this one time, and I think 1 gig. It used the whole gig to run just the code, and since then I never ran any serious code on Google Colab. But that's that for that. So for those that have Anaconda, so what you do is you use Jupyter Notebook. So you come here, type Jupyter Notebook. Okay, so it takes a while, right, to process, and then it takes me to whatever default browser you're using. Okay, because it's kind of a local host stuff. All right, so for those that have your Jupyter Notebook installed and Anaconda installed, you should have this on your screen. So you guys should try to follow me what I'm doing. So do you have this on your screen? Let me know if you have this on your screen. All right, so this is just the files on my system, right? So it's telling me, okay, I can create a new Python file. I come in here and clicking on Python 3. But if you want to dedicate a folder for all this process, you can just create a folder, and that folder will appear here, and then you can click on that folder. For instance, these are the documents in my documents folder, right? So if I want to create my Jupyter Notebook here, I have to enter this folder before clicking on create, right? So it's actually good to have a neat file distribution. But anyway, I'm going to just create this Jupyter Notebook right here in the default file parts. So I'm coming here to write new. By the way, if I have a Jupyter Notebook and I want to just open it up, I come here, or I want to upload here. So I come here to upload. It tells me, okay, where's the Jupyter Notebook I want to open? So I find a location of the Jupyter Notebook is here and all the stuff. And then you just open it. It's as simple as that. But yeah, I'm creating. So I come here to new, and I come here to Python 3. Please make sure it's Python 3 that I say. If you have Python 2 there's a big problem, because Python 2 is completely different from Python 3. Okay, so you can see this almost like what we had on our Google Colab, for those that were using Google Colab, right? Okay, so it's almost the same thing. Yeah, so this is it. Welcome to I'm welcoming you officially to your programming class now, your Python programming class. So the first thing I would like you all to print is what is the common first language to print in Python, whatever programming language you're dealing with, which is the hello world statement. So I want you all to print hello world. Now to run this, you can click on this, right? You click on this to run, but it's always good to use shortcuts. So what I normally do, you can use Control and Enter. If I click on Enter, it goes to the next line, all right? But if I click on Control and Enter, it runs the code, and you can see it printed hello world. This is like the first programming language. So it's like a conventional first language, first stuff to print when you're learning a programming language. So I want you all to print hello world on your screen. So you have hello world on your screen, let me know. If you have hello world on your screen, voila. She said I'm too fast. Where are you? I just printed hello world, that's all. Just for now, don't worry about all these things I'm putting. I'll tell you what everything means, right? So in fact, after now, I'm going to start with the syntax of Python. So for now, don't worry about what this print means, what this bracket means, what this, whatever. Just print this guy. Just print it for the sake of convention. for the sake of the culture. Right? So print it out on your screen, right? So you guys have hello world printed, and that's your first Python code. Congratulations. So let's now go on to print or to do other stuff. Now to do other stuff, I have to create another cell, right? So I come here to this plus sign and create another cell. That's it. So if I want to print any other thing, I want to do any other thing, I can also type and then it will be done. Okay, so it's as easy as that. Easy as that. But now let's get into what Python syntax is about. First of all, I want to point out that Python is an interpreter. Okay, so what this Jupyter Notebook is doing is just to take all these things into my Python interpreter. That's why I said you guys should download Python, right? What you downloaded was Python interpreter that allows you converse with your laptop. Okay, so the first Python file you downloaded, let me just find it somewhere. I think I put it in desktop. Python content, no, not this. So where did I even put that stuff? Okay, not this again. Okay, so yeah, this is the Python setup I downloaded longest time. So you can see this is a Python setup file. But what this guy does is that it allows the Python interpreter to rest on your system. So you can now use the Python language to communicate with your system, right? So now what I'm telling you, the first feature you should understand about Python is that Python is an interpreter. And that means that it runs codes line by line. That's the first thing you must know. And I think it's important that I point it out right now. Okay, so if I tell Python, to print hello world, okay, say hello world, and I come again to say print Cheesy, because Cheesy has been saying a lot on the comment section. So let me just print his name, right? So I come here to run. It prints hello world first before printing Cheesy, as you can see. So the idea is Python runs code line by line. It doesn't, for other languages like Java, for instance, it doesn't allow the entire code to be correct before you can run it. Okay, so let me give an example. If I say print hello world, and I give a very funny syntax, let me just type gibberish. Okay, now see what will happen. Okay, first off, when you're using your print, when you're trying to run your code, it's always, of course, difficult to become here and be typing and clicking on run. So what you do is that you type shift enter. The first time I told you control enter. If you type control enter, it will run your code, but it's not going to create another new cell for you. But of course, in Jupyter Notebook, when you're running your code, it's always good for it to create another cell afterwards. So I'm going to use shift enter this time. Okay, so what do we see? Okay, we see that it tells us that this is not defined, and that's because it checks the first line. Okay, and then when it gets to the second line, it sees that it is not defined, and then it gives you the error. So the idea is that Python actually runs things line by line. It's very important to know that. Okay, so the first thing I would like to talk about is that use hash, right? Use hash to show comments. So I mentioned that Python runs stuff line by line. As you can see, it printed hello world and printed what Cheesy. Okay, the second thing I wanted to talk about is that use hash to indicate comments. Okay, and comments is just a way of telling people what you're doing. It's a way of guiding another user. Okay, this is what I did in this place, right? And it's always good to write comments when you're writing your codes because it's professional that way. Let me put it that way. So if I come here, a comment I can put is that I can say print hello world, something like that. Okay, so I'm just telling my people that, oh guys, I'm about to print hello world. Now, although if I type print hello world without that hash, it will give me a big comment because I'm not following Python syntax. By the way, let me define what a syntax is. A syntax is just the rules of engagement when writing codes. Okay, so I may be saying syntax frequently, and if you don't understand what it is, that's what it is. So for instance, a syntax in English language is that when you ask a question, you put a question mark at the end, right? That's a syntax in English language. So a syntax in Python are just the rules of engagement when writing codes. in Python, which I will still also talk about. So of course, like I said, one syntax is that comments are always written in what? In hash. Okay, so if I type print hello world, like I was about to type, let me type it again, print hello world, it's going to give me an error because I'm not following I'm not following the syntax. It doesn't know what hello is, right? It knows what print is. Print is a keyword, but it doesn't know what hello is. So it's telling me, oh guy, there's a missing parenthesis. He knew I was going to write print, right? So he's telling me, do I mean hello world, which is quite wise of Python. Okay, so but I didn't want to print it. I didn't want to type this like it's just a comment I wanted to give my people. Okay, people reading it outside. I wanted to tell them, guys, I'm about to print hello world. So what I do is that I put this in I put a hash sign in front of it. And if I run this, it's going to run smoothly without yelling at me or returning an error. Okay, that makes sense, right? Does that make sense? For guys that are unable to install your Jupyter, please use Google Colab. I said it already, right? Use Google Colab for now, at least. That's important. Okay, so I said this, that you can write your comments in hash. One thing you can also do to write comments, especially multi-line comments, is to use 3 apostrophe, whatever they call it, right? So I put 3 of that. If I type it 3 times, right, and I come to the middle here, right, I can write whatever nonsense I want to write. It can be a comment, it can be a description, whatever thing I want to write. It's going to run it smoothly without yelling at us. So I can say this is the first Python code. I hope you all are following. Thanks and bye. So you can see that I wrote a lot of stuff, right? And then if I run it, it's going to run smoothly. As you can see, it printed it out for me. But if I'm running this normally, this doesn't change anything in my code. This is just like a multi-line comment, right? It doesn't change anything on my code. So what most people do is that when you're trying to write a function and then you want to just explain what that function does, you kind of write a description of the function. So you use triple apostrophe, right? Instead of just one hash sign. So that's the difference between these two. They are both comments, or I wouldn't say they are both comments. You can call this a comment, you can call this a description, because this can be multi-line and then it doesn't affect anything in your code. All right? Okay, so the next thing I would like to say is that in Python, indentation matters, especially before when in a new line, indentation matters. Okay, so if I type print hello world, right, it's going to work fine. But if I type something like print hello world, you can see there's a problem, right? That's because Python doesn't expect this indentation here. So in Python, indentation are used to show like subheadings. That's how I put it, because I think it's a better way of putting it. So when you have any indented line or indented line or lines, it shows that these guys are under exactly what is on top. So it means that if I'm saying print hello what I'm saying print hello, but this time it's with an indentation. It means that Python is expecting this to take, how will I put it? It should take subheadings from here. But in a way, this doesn't make any sense because a print statement is a print statement. When we get to control flow, where we start using for loops and while loops, you start to see the need of writing indentations. But what I'm trying to point out from this second point or third point is that indentation matters. Okay, indentation matters. Okay, so another thing I would like to say is in Python is that spaces in between operations doesn't really matter. Okay, so if I say something like print and I put a space, for instance, and I say hello world, okay, it's going to print that smoothly, okay? So spaces doesn't really matter. In fact, I can put a space like this. If I print it, it's going to print, okay? So spaces in between texts doesn't really matter in Python, okay? So does that make any sense? But of course, it's always good practice to use the right spacing. So as we go on, I'll explain to you the right practices to use when writing quotes. They call it it's. Does that make some sense? Right now, let me talk about variables, because I think variables are like the building blocks of Python, right? Okay, so variables are just a way of, they call them placeholders. So if just the way you write in maths, for instance, I'll say let x be equal to something, right? So it's just a way of holding that thing. That's what a variable is. So if I say something like let x be equals to 4, x here is called a variable, right? So if I come to my next line and say print x, I don't have to print 4, but it's going to look at, oh, what is x, right? So I've already set x to be 4, and then it prints 4. So if I run this, you see it prints 4. Does that make sense? So that's a variable. That's what a variable is. They are just placeholders. So you can see variables as baskets, okay, to fruits, or you see them as bookshelves to books. Okay, so that's what a variable does. It kind of hold stuff. Okay, so I can come into my next line and say let 4 be equals to something else. Let 4 be equals to hello world. Okay, so if I come to if I now type x is equals to hello world, can anybody guess what this will print? Now don't cheat, don't type it on your own machine, but let me see, can anybody guess what this will print? Will it print 4 or to print hello world? What do you think this will print? Okay, yeah. It will actually print hello world, because I mentioned that Python runs stuff line by line. So first off, I said x is equals to 4, right? I declared the variable x, I called that equals 4. I changed my variable in the next line, right? So I changed this variable and to hello world. So if I attempt to print x right now, it's going to, oh, guy, this is no longer 4, it's hello world. That's the latest assignment I gave it. So once I print that, it's going to print hello world, not 4. Okay? All right, so that is variables for you. So when you're dealing with Python, of course, you can see that 4 is a number, right? Hello world are letters. There are different kind of data types to use when printing, when dealing with Python. The first data type, okay, so let me just type it. Data types in Python, okay? So the first data types are called ints, okay? And ints are basically integers, so they are just numbers, whole numbers, okay? So these are called whole, okay, I didn't put, yeah, you can see I didn't put my so integers, they're basically called ints, and they are just whole numbers, okay? Whole numbers. Okay, the next one we have are floats. Okay, floats, or you can call them floating point numbers. And these are basically numbers with decimals. So they're numbers with decimals. Okay, so the next data type we have in Python are called, you can call Boolean. Boolean are basically where you want to you need true and false. So they can either be true or false. That's what Booleans are in Python. Okay, so yeah, you have other data type. You have none. So none is just like the when something doesn't exist. So none is another kind of data type in Python. Okay, so these are, and then I missed the one very important one, which are strings. Okay, so strings are basically letters. So they are letters, all right? So these are like the 4 major data types you would have in Python. Okay, they are the 4 data types you would have in Python. Okay, is everybody following me? Let me know if you're following me. Okay, great. Okay, so it's important to actually know what these things are, because you'll be dealing with them as we go on. Okay, so like I said, x was 4. So if I want to check what kind of data type x is, I use the type function. So you type like this, and you open parentheses, and then you just type X. Okay, so if I run this, it tells me the kind of data type this is, okay? And then it prints string, like you can see str, okay? It means string. So let me also define other kind of data types. So let me say A is equals to 1, B is equals to 1.2, C is equals to false, D is equals to, okay, gracious, that's the last name I saw in the comment section, so I'm using his own name. All right, so, and then E is equals to none. So I'm just trying to show you that, all right, so these are the, Duman, he said, how do you edit in a previous cell? You just go to the cell and edit now. So as simple as that. Just come, put your mouse there and edit and run again. Okay? Okay, so let me now type, so I'm going to type A. I'm just going to copy that because it makes life easier. Okay, so type A, type B, D, E. Okay. Okay, sorry, I should have used the print statements. Okay, because the print statements is used to show what a variable is. So whenever you're using a print statement, you're telling Python to tell you what this thing is. Okay. So I'm using the print. Okay, let me just copy these guys again because it's a waste of time. So I'm just trying to put print in front of all these guys. Nothing serious. Okay, yeah, this is what I wanted to have. Okay, so as you can see, Kamaluddin, you said type X tells you name error. Yeah, one thing about Python, it checks whether you defined X before. So as for me, I've defined X to be hello world, and that's why it's printing it out. So most likely, or definitely actually, you've not defined X to be something. So it's telling you it doesn't know what X is. It's a name error, right? Name error, X has not been defined. Most likely that's what it will tell you. Okay, so you have to define X, call X something before you do that. As you can see, I defined this variable. I called X1, I called by.2, I called C false, I called D gracious, I called E none. And if I print the type of all these guys, it's telling me that this is an integer, right? So A is an integer, this is the first print statement, so this was printing first. B is a float, so you can see it's like a decimal number. C is Boolean, so this is false. And D is gracious, right? As you can see, is a string. And then, of course, E is a non-type kind of data type. So, yeah, so it's important to note that. Okay, so let's stick a little bit with numbers. So in Python, you can do a lot of stuff, right? So I can just say something like print 1 minus 5 or something like that. If I print it, it's going to do the arithmetic operation for me. Simple as that. So you can do a lot of operations. Of course, you know what plus is already. I don't have to start to say what those are. So of course, your plus is for plus, minus is for minus, multiplication is for multiplication, slash is for division, okay? So if I have my slash like this, if I see something like 3 divided by 5, if I print it out, it's going to give me 0.6, which is normal stuff. But what I want to dwell on for a while is multiplication, okay? Or let me not call it multiplication, let me call it raised to power. So if I do something like 2 and I put it twice, normally if I do something like 2 times 3, it's going to do 2 times 3, which is 6, okay? But if I do something like 2 and I put that twice, okay, it's going to do 2 raised to power 3, which is 8, okay? So I can do a lot of stuff. Now, if I want to do what we call floor division, I use the slash sign twice. And what that does is that it just returns, okay, it just returns the whole number, okay? And normally this should be 2.5, right? But what it does is that it just returns the whole number if I do this. So there are times that you guys will need to, you just care about the whole number parts of division, and then you do this. Now, if you only care about the remainder parts, what you do is you use the percentage sign, okay? So if I do 2 percentage of 5% of 2, I'm going to get is 1, because normally this should be 2 number 1/2 or 2 remainder 1, right? So this will give me 1. So these are important things to talk about. So let me know if you guys have any question. You said you didn't get how I define X. That was the first thing I talk about. Variable assignments. You just use the equals to sign once. So if I do X is equals to anything, right? It can be a string, it can be an integer, it can be anything, right? So if I do X is equals to anything, that's how I defined it. So I can just call X, okay, Kamaluddin, right? And I've defined X. So if I print X in my next line, it's going to print that name out, right? So that's how I define it. The next thing I want to talk about is comparison. Okay, so it's just this one now returns through or 5. So if I call A, let me say I call A 23 and I call B 48. Okay, so I can compare. Okay, I can try to. Okay, so the man asks what's the difference between print type X and then print X. Okay, if you're printing type X, you're trying to check the data type of the variable you declared. Okay, so if what you can see is that it's printed int, class int. Okay, so this is data type of this variable. But if I printed A, it's going to give me 1. Okay, so that's the difference, right? That's the difference between that. So I can actually check. If you want to check if A is equals to 1, which I think you use very well, so it's important to know this. What I do is I use equals to sign twice. So this is telling me that check if A is equals to B. So there's a very big difference between this and this. In fact, if I do this, it's not going to work. Okay, if I do this, okay. What I'm doing is, if I do this, what happens is that it's telling Python now to set A to be equals to B. Okay, so if I print, let me print A. And then I'm going to print B. So you guys will see. You can see what happened there. Okay, so I said first, I said let A be equals to what? 23, and let B be equals to 42. But I now said let A be equals to B. So if I print both of them, it's going to give me, it's going to change B to what? It's going to change A, I beg your pardon, to B. And that's why I printed 42 for both of them. But that's not what I wanted to drive at here. So let me copy this code again. Because it is. So I'm just going to leave that on my screen. What I wanted to do is to check if A is equals to B. Okay, so I use this twice. Okay, is everybody with me? So this is like a form of checking if a condition, checking if a condition is actually correct. Okay, so if I do this and I type enter, it's going to print false. This is going to return a Boolean. Okay, this is good for returning a Boolean because really A is not equals to B. Okay, but if I do a less than sign, is A less than equals to B? Is 23 less than equals to 42? Yes. So if I print this time, it's going to return a true. Okay, but if I do it this way, greater than, it's going to return a false. All right. Now, if I want to check if A is not equals to B, there are times where you need to print statements where, you want to make sure that this is not equals to this thing, okay? So what I do is I use, I'm not going to have issues, okay. So I use this sign here, and this is like not equals to, okay? So if this is checking if A is not equals to B this time. So what do you think it will return, true or false? Let me hear from you guys. What do you think? Okay, yeah, great. So this will return true. Okay, yeah. So as you can see, this returns through. Okay, so that's one thing I also wanted to talk about. Okay, so now let's get into data structures in Python. Okay, because in Python, you'll be dealing with a lot of data structures, and they're important for you to understand how to manipulate with them. Data structures are just stuff you use to hold data, basically. Okay, so you have a couple of data structures. One of the most popular ones you have are called lists. Now, a list are used to hold variables, more than one variable. Okay, so if, for instance, I want to hold the score of people I want to hold the grades of people in a class, I have to define a list because maybe there are 10 people in a class now, and I want to know what their grades are. I'm going to use a list to hold that. And how do I define a list? I call a list by using this square bracket. Okay. So when you open a square bracket, you're telling Python, oh, guy, I'm trying to define a list, right? So like I said, list can take more than one input, and then those guys are separated with comma. So if I want to, for instance, let me not use A, let me say scores in the class, okay? So I want to print people's scores in the class. Let me call it scores, and I take a list. So let's say the first person has 40%. The second person, okay, M does is 40. Second person has 90%. The third person has 20%. Person has 17%. This one has 90%. Okay, so this is like the score of 5 people in a class. And rather than calling this one after the other, what I can do is that I can use a list to define all of them at once. Okay, I can use this list to define all of them at once. Okay. So how do I identify, for instance, if I want to pick the first name in that list or the first entry in that list, how do I do it? You use what they call indexing. I think for those that are not following me, maybe you guys are not getting something right. After this class, you can send me a text and then we'll see what we can do about it. Okay, but I guess some other people are following. So if I want to get, for instance, the first name or the first item on this list, you do it through what we call indexing. Let me point out, or let me say now that Python actually counts from 0. Okay, so this would be my 0th index. So this would be 0, 1, 2, 3, and 4. And although there are 5 elements here, this is the 4th index. Okay, so again, let me count. This is 0, 1, 2, 3, and 4. Okay, so if I want to access, for instance, the first element in the list, what I do is I call the lists and then I use this again, all right, to take my 0th element. Yeah, so if I print it out, it's going to give me 14. Okay, this is for accessing the elements in the list. If you want to access the individual elements in the list, if I want to access the second element in the list, I change this to 1. Okay, and I run this. Does that make sense? Does anybody follow me? Let me know if you're following me. Let me know if you're following me. Let me take a break and know if you guys are following me. Okay. I'm sure a lot of people are wondering why all these things, why all this, it looks like gibberish, right? But in all honesty, if you don't know the basics, you have problems when we are beginning very serious stuff. Okay, that's why I need you to understand all this stuff. Does that make sense? Okay, so let's say I want to access this last element in the list. What do I do? Scores. Okay. What number do I put now if I want to access the last element in the list? Great, because like I mentioned, Python counts from 0. Okay, so I do 0, 1, 2, 3, 4. So if I print this, it's going to give me the last element in the list, which is 19. Okay? Does that make sense? Okay, great. But the thing is, there are times when you can have very long lists, okay? And then if you want to print the last element, for instance, it's required to start counting. 1, 2, 3, maybe you have 100 elements, but you don't know you have 100 elements, right? It will be crazy for you to start counting 0, 1, 2, 3, 4, 5, 6, 7, and all those stuff. It will be crazy, right? So you can also count backwards. Okay, Python allows you to count backwards. So how do you count backwards? Now the thing is, Python counts backward from -1. I know this is crazy. You're asking me why is Python not counting from 0? Well, I don't know. I didn't create the language, but it counts from -1. So if Python is counting, for instance, the index of this list backward, it's going to start from -1, -2, -3, -4, and -5. So if I want to print the last element, I don't want to care the number of elements in this list. Maybe it can be 92 elements in the list, but I want to make sure I print the last element. What I do is that I access the list again through indexing by creating this, and then I put a -1. So if I run this, it's going to give me the last element again. So this and this are the same thing. Someone's raising his hands. Okay, let me allow you. Okay, do you want to say something? Okay, what will happen is text. Say what you want to say in the comment section. If I think it's something urgent, I'm going to read it out. But if it's not something urgent, I'll leave it to the end of the class so I have time to ask questions. Does that make any sense? Share goes in. Does it make sense? Okay, yeah. How do I get the skill bracket? Just type it on your keyboard. I think I also have issues with my keyboard keys not being very accurate, and that's what I was guessing the other time. But find square brackets on your keyboard and then type it. I don't know your system, so I can't say how you'd get square brackets. Okay, so that's that. So if you want to add elements in the list, for instance, I want to add one more element. There was a new student that joined, and then he also took my test. Okay, and this guy had 68. How do I add him in the list? I use the append method. For now, I'm still going to explain what methods and functions are, but just take it for me that I use the append method. And how do I do that? I do scores. I, of course, take scores like this, and I press dot append, and I open a bracket like this. Okay? This guy right now is called a method. Now, there are lots of methods used for lists. Okay? There are lots of methods. In fact, if I do something like the directory of scores, this will give me all the possible methods I can use with a list. Okay, so these are all the possible methods I can use on a list. You can see append, clear, copy, count, extend, index, insert, pop, remove, reverse, sort. Okay, so all these things I can do on a list. Append is for adding an element to the last part of the list. Clear is for clearing the list. Copy is for copying the list. Okay. Count is for counting number of elements in the list. Extend is actually used for adding more than one element in the list at different points. Index is to check the index of the list. Insert is to insert an element at any point in the list. Pop is to remove the last element in the list. Remove is to remove any element in the list. Okay. Reverse is to change the order of the list. So maybe it was counting from 1 to 3, 4, and went into 4, 5, 4, 3, 2, 1. Use reverse. And then sort is for sorting a list. So if a list is haphazard and you want it to be sorted, you maybe ascending or descending order, you use sort. Okay. So let me not confuse you guys with this. So I'm going to delete this and then move on to this. So I said I'm going to use the append function. Okay. So in Python, you have what called docstring, and docstring is like the official documentation, right, of different functions. So when you have a function, there's this documentation that guides you on how to use the function, right, and what the function does. So what you can do to get the docstring of any function is to type Shift and Tab on your system, right? So you type Shift and Tab on your system. So if I type the docstring now, it's telling me that I can append an object to the end of the list. Now, an object is just anything, okay? Everything in Python is an object. So it's telling me that I can insert an object to the end of the list. That's what this append method does. Okay, so remember this was my list. Okay, 40, 70, 20, 17, and 90. So if I want to add, for instance, I want to add 68%. A new guy came in and he has 68%. What I do is to do scores.append. So if I print scores right now, you will see that 68 has been added to the end of the list. Okay, so we also have other functions. Okay, I mentioned pop. So if I want to remove the last element in the list, again, you check the docstring, you can see that remove and return at index, but at default is set to -1. And you know -1 means what? The last index in the list. So if I do scores.pop -1 again, although it was set to -1 by default, but I can set it to -1 again, and I do when I print scores. I print scores. You will see that the state has been taken off. Okay? Does that make any sense? If I want to remove, say, the second index now, that would be 20, right? Okay, now that would be 17. Okay, so if I print it now, you can see that 17 has been removed. Okay, so you can also use remove, you can use extend, you can use sort. I think sort is also I'm not going to go over everything, but I'm going to talk about the ones that are useful for you. So you'll be using sort a lot too. So if I want to sort this, maybe I want to sort it in ascending or descending order. Again, it's always good to check the doc string. So I do tab and shift. Okay, so you can see it's used to stable sorts, okay, in place. Okay, and then it's telling me that the reverse is false. It means that it's not going to reverse it. So if I do this, it's not going to take any arguments. Remember, what it does is that it sort this in ascending order. Okay, but if I want it to be reversed, what I do is I do reverse is equals to through. If I run this, it's going to change, reverse this. Okay, but if I just want to take the default values, I do this and it runs. Is everybody following me once again? Let me know if you're following me, please. Okay, great. So if I want to check the number of elements in the list, this one you use often. You use the len function. Okay. Now there's a difference between function and methods. And let me just point it out straight out of the gates. Now a function, you can see how this len function is called. I called len, and then I opened my brackets. This bracket means I'm trying to call something. Okay. While a method, it's how will I put it? A method is pointing at an object already. As you can see, this was pointing at scores. So I have to do scores.append. But a function, I don't have to use scores.append. I rather just do append, although append is not a function. Len is rather a function. So in this case, I'm not doing something like scores.len. I will just do len. Okay, so now let's see what this len does. It said it returns the number of items in a container, all right? And look at it. This is like the parameters it takes. So the first parameter or argument it takes, let's call it an argument actually, because doing declaration is called an argument. So it's asking me what objects to check for. So now I want to check the number of elements in this list. So I'm going to pass this list as an argument. So if I do length of score, it's going to give me 4, all right? Because this is the latest length of score. Okay, I can also do it for strings as well. For instance, if I'm just giving a variable called title and I call this Python, okay, Python for beginners, I can also do the len of this, right? I call the len function and I pass this title as an argument. Okay, so if I run this, it's going to count the number of elements in this string. It's going to count the number of elements in this string. So if I run this, it's telling me that there are 20 elements in the string, including spaces. So if I close the spaces, it's going to reduce. Because close the space, you can see it has reduced to 20. Okay? Does that make sense? Okay, it's unfortunate that I didn't use a slide, or I'm not kind of naming all these things. But like I mentioned, this is called indexing. It's a very important concept in fact, in data science, we use a lot, indexing, fast indexing especially. Okay, so I want to talk about what we call slicing, because slicing is one thing you can also do to a list. Okay, now let me also say why I'm dwelling so much on lists. You use lists a lot. In fact, lists are one of the most important things to learn when it comes to data science. So in this course, what I will focus on are the things you need particularly. I wouldn't, for the sake of ceremony, go into stuff that you won't be applying, right? So I'm dwelling on lists a lot because you'll be dealing with lists. In fact, if you don't know how to wrangle lists, if you don't know how to play around with lists, you have problems get into NumPy and Pandas, which are libraries you use later on in this course. Okay, so that's why I need you to understand what lists are and how they use them. So that is a list. Okay, but now let me define that list. Let me call that list names. Let me just give some names. Let me call David, because that's my name, right? Let us call this. Let's assume these are names of people in the class. So allow okay, because I also saw his name in the comment section. I'm also seeing Akugu. Let's put his name there. Or as I might say in the comment section, just trying to find list. Okay, okay. The same people, Adidamola, okay. Let me also put Adidamola there. Okay, let me just find names I know. Toby, that's a very fine name. Nicholas, Nick, that's a great name. Annabelle, Anne, whatever. Sophia, that's a great name. Okay, so this is I just found a list of names, right? And then there's what we call slicing. Okay, slicing is a way of assessing parts of the list. Okay, it's a way of assessing just parts of the list. I mean, I don't want to call, for instance, if I call all the names now, if I print all the names like this, it's going to print my list. As you can see, it printed all the names I used. But say I want to only print out the first 3 names. Okay, I use what we call slicing. And slicing is almost like indexing, only that this time you add an extra feature, which I'll explain now. So if I want to do slicing, I'm going to call, of course, the name. This is the list I want to slice. I'm going to call it. Then, of course, just the way it is in indexing, I'm going to open a square bracket. So now, if I'm doing slicing, I'll first take out the first where I'm going to start from. Okay. So I wanted to print the first names, or the first 3 names, right? So my first name will be the first index. So that will be 0. As I've mentioned, Python starts from 0. Okay. If I print this, it's going to print just my first name, right? Just the first element, which is good. Okay. So if I want to print, for instance, not just the first name now, I want to print the first 3 names. What I do is that I use this column. Once I put column, I'm telling Python that guy, I'm about to slice, right? Slice this thing for me. Okay, so if I want to print the first 3 names, remember that Python starts from what? The first, from index 0. It counts from index 0. So I do 0, 1, 2. Okay, 2. But there's a catch here. If I put 2, Python stops at 1. Let me print it out first so you see what I'm talking about. Good. Now, this is the catch. When you're using slicing, Python subtracts 1 from this end index. So normally, this will be 0, 1, 2, right? This will be 0, 1, 2. Am I correct? But Python removes the last one. So Python sees as I'm stopping at 1. It doesn't take the last index. This is also one very important thing to point out. Okay, so when slicing, Python doesn't take the last index. It kind of removes the last index. Does it make any sense now? Okay, fantastic. So that's how slicing works. There are a couple of things you can do. Most of the time when you're working with, when you start from the 0th index, you can just take it off completely. Once you don't put anything and you put semicolon or you put colon, Python assumes that you're starting from the beginning, all right? So if I run this, it's going to print the same thing out. Now, also, when I don't care about where to end, for instance, I want to just make sure the end is the last item in the list. What I do is that, okay, let's say I want to start from this guy. So this is 0, 1, 2. So I print 2 there, right? So if I want to get to the end of this list, Sophia, I wouldn't put anything. There's no point putting anything here. Okay. So if I run this, it's going to run. Okay. If I run that, it's going to run. If I put -1, look at this. I mentioned that Python what takes out the last element in the list. So Sophia is gone. So how do I remedy this? How do I remedy this? I put 0. Okay. Oh wait. Okay. Basically, what happened here was that if I print them starting from 2 to 0, it doesn't make any sense. And that is giving me an empty list. Okay. So if I print 2, I'm telling Python, oh, start from 0, 1, 2, start from this place, but end at 0. 0 means year, right? So I'm telling you to start from this place and end here. So it doesn't make any sense. There's nothing in between, and that's why it's printing an empty list. If I want to end, if I want to stop at the end, what I just do is to leave this place blank. That I was trying to say last time. So I leave this place blank like this, and I run it. It's going to end at Sophia. Okay. But if I put -1, don't be what's happening? Don't be too excited to think that it's going to stop here at Sophia. I mentioned that Python takes out the last index automatically. So, but that's when you're using range, mind you. That's when you're using what? Range, or when you're using slicing, as you can see. So whenever you're using semicolon, that's when Python takes out the last index. Please, that's important to do. Don't confuse it with when you're just printing it with like indexing like this. If I print something like -1, of course, you can't take out the list. It's going to print out the last elements. Does that make any sense, guys? Okay, great. Okay, there's other data type I also want to discuss. Those are called tuples. Okay, tuples are almost like list. The only difference between tuples is that tuples are immutable. Okay, tuples are immutable, and that means that you cannot change a tuple. So there are times when you are someone said doesn't understand slicing. I said slicing is just a way of taking a chunk of a list, just like you're slicing the list, as you said. Okay, so you're taking a chunk from an entire list. And how do you do that? After indicating your first element where you want the thing to start from, you put a colon like this. Okay, and this is like your ending element. So this is start and this is stop. So I'm telling Python to stop at -1, which is, of course, should be my last index. But I also mentioned that when you're doing slicing, Python takes away the last element by default. Okay, so that's why if I print this, it's not going to print Sophia. Okay, if for instance, I'm doing something like 2, 6, this is 0, 1, 2, 3, 4, 5, 6. Python would not print Anne. It will stop here at Nick. Okay, so if I print this, it's going to print. You can see from 2 to Nick. Okay, I hope that makes sense. Okay, so I was saying that another thing to discuss is tuple. Okay, so basically, what are tuples? Tuples are almost like lists, only that in the case of tuple, you cannot change the elements in the tuple. Okay, you cannot change elements in tuple. That's just difference. And then how do I do that? How does tuple differentiate from list? In list, I define lists using what? Square brackets. But I define tuples using normal brackets or parentheses, like you can see. So if I want to change, okay, let me just show you that this is a list. So if I type of names, you can see it printed a list. Okay, so type is a way of, I think I've mentioned type before, right? Yeah, I have, definitely I have. So type. So type is a way of just checking the kind of the data type you're dealing with. So as you can see, the type of names is a list. But if I want to change this to a tuple, what I do is that instead of me using square brackets, okay, instead of me using square brackets, I use parentheses. So I change this to open parentheses, and then I change this to close parentheses. Okay. Now, if I print it, definitely going to be the same thing. Okay. With tuple, I can also do indexing, just the way you saw it. So if I want to index from maybe 2 to 5, it's going to work the same way, right? The chunking, slicing, everything will work perfectly. Okay, but the only difference is that while I can add, remove, do a lot of stuff to a list, I can't do those to a tuple. For instance, I added what? There's a place I added a name using append, right? So what is that? Yeah. So I added append to this. So let me also, if I wanted to append, names dot append. If I want to append, maybe I found out there's a newcomer in the class and the person's name is Gates. The person's name is Gates. Okay, so if I attempt to append this, what will happen, right? So it tells me that a tuple has no attribute append. A tuple, you cannot add a new element to a tuple. Okay, but if this was a list, so sorry about the stuff. My mouse may do sometimes. Okay, so like I said, this because this is a tuple. Because this is a tuple, it cannot what? I cannot add new elements. I cannot alter it. So it's always good to use tuples when you know you have a list and you don't want any other person to touch it. You want it to be the same thing, yeah and amen. And you don't even want to by mistake, change that list yourself. So instead of using a list, you use tuple. But aside from that, tuple and lists are the same thing. But for the most part, you'll be using tuples and you'll be using lists. So you don't have to worry ahead about tuples for now. So I'm going to stop. I'm going to just talk about one more data type, which I think is very important as well, and then we'll call it a day for today. Okay, so and those are dictionaries. Okay, so dictionaries allow you add extra functionalities to when you're defining a data, for instance. So that's what a dictionary does, basically. That's what it does. So what you can see dictionaries as just the way you see a normal dictionary. If I want to check the meaning of a word, I find that word. So I have like a key. So I don't care about any other word before or after. I locate that word. And then once I get that word, I can see the meaning of that word. That's the way it is in dictionaries. So a dictionary just contains what we call key and value pairs. Okay? That's what a dictionary is. Okay? So a dictionary, as you can, in lists, you can see these are just values. I just called this. Okay, so name is equals to that. Okay, but in dictionary, you have to define a key before I define my my values. So you use dictionaries when you want to define a lot of variables in just one variable. For instance, you want to define the name of students, for instance, and I also want to define maybe their score or something like that, right? Or maybe their gender. I can define everything in a dictionary. So I'm going to do that right about now. So let me call this let me just call this information. Okay, student information. Let me just call it student info. It's always good to use descriptive words when you are defining or creating a variable name. It's always good practice. So I call it student info. And then it's always good to use lowercase all through. And then when you have, maybe you have two words, it's good to split them using underscore. You don't do this. Because Python is saying student at something, Python is saying info at something. So this will throw an error. So you space it out using an underscore. Okay? I hope you are good. Okay, so let's now define a dictionary. Now you define a dictionary using curly braces. Okay, curly braces like this. Okay, so like I mentioned, a dictionary we have what we call a dictionary we have names, right? Then it would have values. Okay, so a dictionary we have keys. I beg your pardon. A dictionary we have keys. and then it would have value. So the first thing is to define my keys. So let me say the first thing I want to define are the names of in the class. So let me call it names. Okay, let me call it names. And then to split my names and value, I use a column like this. So it's basically, let me just put it here as a comment. So I have dictionary like so. We have keys, this, values. These are dictionaries. This is like the syntax of a dictionary. So I have my keys, first off, which I can call a title, right? You can call them like a title, okay? And then you have values. So let's start. I'm not going to waste too much time. Let me just copy these lists because I don't want to type. Sorry. So names, and I place this there. Okay. So I can now go for another case. Let's say I want to also get their scores. So I come here, right? If you like, you can create another tab. So create another tab bar so it doesn't confuse you. So I come here and type something like scores, okay, and then open another list. Okay, these are numbers this time, so I don't want to put apostrophe, as you can see here. So when I put something like this, Python will see 21 as a letter. That's important. That's the difference between a string and an integer or a float. Okay, so I wouldn't put it in parentheses. So I'm just putting 21. Let's see, this one had 34, this one had 45, and this one has 16 or 12, whatever. Okay, so I can define that list. Let me just say for their gender. Okay, so I can say call this gender, and then this is my key, remember? And then my values now can take another list of male. I'll call this a female. Female, and then male. Okay. So what I've just defined right now is called a dictionary. Okay. You can see it has keys and value, keys and value, keys and value. So I can get the values of a dictionary just the way I did indexing. Okay, so first I'll call my variable, which is student info dots. Okay, so I don't need the dots, just the way I did indexing. Okay, so here if I say I want to get the names of students, what I just do, after calling the student info, I open the square brackets and put names there. So if I print it out, it's going to print out this list of names. Okay. If I call scores, it's going to print out their scores. Okay. If I call gender, it's going to print out their gender. Another way to do this is to use the dot get method. Okay. So I can also do send info dot gets. Okay. If you run this, you can see return the value for key if it's in a dictionary. Okay. So it returns the value of a key in a dictionary, basically. So if I want to return the value of, say, names again, I do that and it gives me the same thing. So I can use this indexing style like this, just where you index a list, or I can use the .get method. But we use this .get method because if I attempt to print a key that has not been defined, say I typed email. Okay, let me copy this. So I'm not going to confuse anyone. So if I try to print email, now I didn't define email in this list, all right? In this dictionary. If I try to print the values of email, it's going to give me an error, right? It's going to tell me, of course, key error. email, doesn't know what email is. So there are times when you want your code maybe to return something else, okay, not an error. That's when you use this get. That's where get becomes important, okay? Because whenever you run anything that is not in the dictionary, it's going to return none. And in fact, if I want it to return something else, I can call that thing right out of the gate. Okay, so let's say now, of course, I have not defined email. Okay, so if I come here and print email, email is going to return none. Okay. So you can see it didn't yell at us, it didn't give us any error. Let me just, yeah. So you can see it returns none, okay? It returns none. But if I want, okay, whenever this key is not there, give me something instead. I can still come here, right? So after giving this, if you go again and check the doc string, you find out that it's telling me that, oh, check for this key. But if this key is not available, return defaults. But default is done. But I can change this default to whatever I want to, right? So if I want to say, if it's not available, okay, let me copy this again, put it here. So if it's not available, let's say, just return not available, okay? So I can just say not available, okay? So as you can see, this time it returned not available. Does that make any sense? So it's always good sometimes to use this .get method rather than using indexing, because it attempts to call a particular value that has not been defined in your dictionary, is going to throw an error, as you can see, a key error. But if I use this get, it's just giving me a non-value, which shows that, oh, this thing doesn't exist. But if I also want to customize it my way to whatever I want, of course, I can customize it by putting whatever I want here. Okay, so I'm going to end this class right now. Thanks for your time.